A cut line looks simple. The risk is everything the line can meet: silica dust, exhaust fumes, kickback, blade fracture, falling material, electricity, vibration, noise, slips, falls, and forceful handling. Plan the cut before the blade starts, because several hazards can arrive at once. Start with the actual job and the actual equipment. Check condition, guards, and maintenance status. Review the manufacturer's recommendations. Confirm the material, depth, and sequence. Look for obstructions, embedded surfaces, and unstable sections. Identify nearby people, and plan for water, slurry, and cleanup. Develop the hazard identification, risk assessment, and controls for each type of job and item of equipment. Consult the operator, supervisor, and affected workplace parties before work begins. Before cutting or drilling, locate and mark existing services and structural components using the site's approved process and reliable information. Drawings and markings are planning inputs, not proof by themselves. If the proposed work will cut a structural component, seek structural engineering advice. Do not treat this generic diagram as service locating, engineering advice, or a site-specific assessment. Plan the cut section before it becomes a falling object. Identify unstable masonry, cores, panels, and other pieces that may shift when the cut is completed. Decide how each piece will be supported, removed, and handled without putting people in its fall path. If cracking, movement, or instability appears, stop and reassess. Select equipment, blades, bits, guards, stands, anchoring, and power supplies that suit the material and task, and keep them maintained. Operators, including people using hired equipment, should know how to work safely and demonstrate competency. Depending on the circumstances, that may involve training, experienced supervision, or competency assessment. A generic animation cannot prove that someone is competent. Provide safe access and a controllable working position. Establish barricades and an exclusion zone before the tool starts. Then keep nearby workers and the public outside it. Plan communication, supervision, and the safe removal route for cut pieces. The barrier on screen is a planning symbol, not a site-specific exclusion zone design. Dry cutting bricks and concrete with diamond-tipped blades can create very high silica dust levels. Use source controls suited to the task, such as water suppression or on-tool extraction, and keep them working effectively. Petrol-powered cutting equipment can create dangerous exhaust exposure, including carbon monoxide. Consider the location and ventilation before selecting combustion-powered equipment. Respiratory protection may support the controls, but it is not the whole control system. Water can control dust, but it introduces another pathway that must be planned. Use suitable electrical protection. Keep leads and connections away from water and slurry. Collect slurry and maintain stable, slip-resistant access. Plan cleanup before residue spreads or dries. If slurry pools near electrical equipment, protection fails or access becomes unsafe. Kickback is the sudden and violent movement of a saw away from the cutting surface. It presents an extreme risk to operators and bystanders, with handheld saw operators particularly exposed. Binding, an obstruction, an unstable section, or a loss of control can turn the tool's energy back towards the operator. Use the equipment only within the planned method and manufacturer's recommendations. Do not improvise around repeated binding. Pause and reassess when conditions no longer match the agreed method. Warning signs include a visible dust plume, failed water or extraction, repeated blade binding, unexpected reinforcement or an unidentified service, movement, cracking, or an unstable cut section, pooled slurry near electrical equipment, damaged or unsuitable equipment, or anyone entering the exclusion zone. Stopping is a control, not a delay to work around. The site-specific system may include a risk assessment, safe work procedure, JSA or JHA, equipment instructions, service location evidence, permits, inspection records, and engineering direction. A SWMS may be required when the cutting or drilling forms part of high-risk construction work, under the requirements applying in that jurisdiction and on that site. It is not required for every task simply because a saw or drill is used. Check the trigger and current local regulator requirements. For this WA topic, read the WorkSafe WA Code's practical controls with the current Work Health and Safety Act 2020, the Work Health and Safety General Regulations 2022, and current regulator advice. The code contains older legislative references. Do not treat those as the current framework. BlueSafe can help organize practical WHS documents and evidence, but documents do not replace competent people, physical controls, or site decisions. Plan the cut before the blade starts. Get started free with BlueSafe.